Landing on Titan would not feel like landing on a moon. It would feel like arriving on another Earth. But wrong. The sky would not be black. It would be orange, thick, hazy, heavy with alien clouds. The ground beneath you would not be dry rock like the moon or red dust like Mars. It could be frozen water ice as hard as stone, dark organic sand, or damp terrain shaped by liquid methane rain. And above you, Saturn would be hidden behind the haze, a giant planet nearby, but almost invisible through Titan's thick atmosphere. That is what makes Titan so strange. It is one of the only worlds in the solar system where you could stand under a real sky, a world with weather, clouds, rain, rivers, lakes, shorelines, but nothing there belongs to us. The rain is methane. The lakes are hydrocarbon. The ground is colder than anything humans can survive. And the air, though thick, is completely unbreathable. Titan looks almost familiar until you remember that it is deadly. Tonight, we are not just asking what Titan is. We are asking what it would actually feel like to land there. The descent through the orange atmosphere, the silence after touchdown, the weak sunlight, the strange gravity, the cold pressing against every system, the alien smell you could never breathe, the feeling of standing on a world that looks like Earth's shadow. Before we go deeper, if you enjoy calm cinematic space documentaries made for sleep, mystery, and deep cosmic questions, make sure to subscribe to Theories Before Sleep. Because Titan is not just another moon. It is a place where the universe almost copied Earth, then changed every ingredient. So get comfortable, lower the lights, and let's descend through the orange clouds of Saturn's largest moon to find out what it would actually feel like to land on Titan. Titan does not behave like a normal moon. Most moons are exposed, airless, quiet, bare rock and ice under a black sky. But Titan is different. Before you ever reached its surface, you would know something was wrong. Because Titan has a sky, not a thin trace of gas, not a weak exosphere like many icy moons, a real atmosphere, thick, heavy, orange, a moon wrapped in weather, a world hidden beneath haze. And that is why Titan has fascinated scientists for so long. It is Saturn's largest moon and the second largest moon in the entire solar system, smaller only than Ganymede. It is so large that it is bigger than the planet Mercury, even though it has less mass. If Titan orbited the Sun directly instead of orbiting Saturn, it would feel less like a moon in our imagination and more like a small planet. Its diameter is about 5,150 kilometers. Its mass is enormous for a moon, and it orbits Saturn at a distance of roughly 1.2 million kilometers. That may sound far, but in Saturn's system, Titan is one of the great central worlds. It is not a small captured object drifting on the edge. It is a major body, large enough to hold on to something most moons lose completely: an atmosphere. And not just any atmosphere. Titan's atmosphere is thicker than Earth's. If you stood on Titan's surface in a protective suit, the pressure around you would actually be higher than the pressure you feel standing at sea level on Earth. That detail alone makes Titan feel strange, because on Mars the atmosphere is too thin. On the Moon there is almost none. On Europa, Ganymede, Callisto, and most icy moons, the surface is basically exposed to space. But Titan is covered, wrapped, protected in a dense blanket of nitrogen, with methane mixed into it, creating a chemistry that feels almost like a frozen version of early Earth. And this is where Titan becomes truly extraordinary. It is the only moon in the solar system with a thick atmosphere, and it is the only world besides Earth known to have stable liquid on its surface, not water. Titan is far too cold for liquid water to flow on the surface. The surface temperature is around minus 179 degrees Celsius. At that temperature, water ice becomes as hard as rock. It forms the ground itself. But methane and ethane behave differently. On Earth, methane is a gas. On Titan, it can fall as rain. It can carve river channels. It can collect in lakes. It can form seas near the poles. Titan has weather, clouds, rainfall, drainage channels, shorelines, a cycle of liquid moving between surface and atmosphere. Not a water cycle, but a methane cycle. And that is why Titan feels so familiar and so alien at the same time. It has landscapes shaped by liquids, like Earth. But the liquids are wrong. It has an atmosphere, like Earth. But the air is unbreathable. It has dunes, rivers, lakes, clouds, and seasons. But everything is built from colder chemistry. Titan is not a copy of Earth. It is like Earth's shadow, a world where the same ideas exist, but with different ingredients. For centuries, Titan was a mystery because we could not see its surface. Astronomers knew it was there. They knew it was large. They knew it orbited Saturn, but its true nature remained hidden. The problem was the haze. Titan's atmosphere is full of complex organic particles created when sunlight breaks apart methane and nitrogen high in the atmosphere. These molecules recombine into heavier compounds, forming a thick orange smog. That haze blocks visible light. To ordinary telescopes, Titan did not reveal mountains, craters, oceans, plains, or dunes. It appeared as a fuzzy orange ball, a moon with a hidden face. Imagine trying to study an entire world for centuries and never seeing the ground. That was Titan, a place everyone knew was important, but no one could properly see. Even when spacecraft began exploring the outer solar system, Titan remained difficult. Voyager 1 passed by Saturn in 1980 and gave scientists their first close look at Titan's atmosphere. It confirmed that Titan was wrapped in a dense layer of haze, but the surface still stayed hidden. The cameras could not penetrate the orange veil. Titan remained secret, and that secrecy made it even more fascinating. What was beneath the haze? A frozen desert? A global ocean of methane? Cratered ice? Organic mud? Smooth plains? A world covered in strange chemistry? For years, scientists could only guess. Titan became one of the most mysterious places in the solar system because it was not empty and obvious. It was hidden, and hidden worlds invite questions. Then Cassini arrived. The Cassini spacecraft reached Saturn in 2004, carrying with it one of the most important probes ever sent into the outer solar system. Huygens, a small lander designed to do something no spacecraft had ever done before: descend through Titan's atmosphere, touch its surface, and show us what was beneath the haze. On January 14, 2005, Huygens entered Titan's atmosphere and began falling. Slowly, under parachute, through orange clouds, through layers of haze, through alien air. For the first time, humanity was descending through the sky of another moon, and as Huygens fell, it sent back images, not from orbit, not from a telescope, from inside Titan's atmosphere. At first, the world was blurred and orange. Then shapes began to appear, dark channels, branching valleys, bright highlands, flat plain, features that looked disturbingly familiar, like river systems seen from above, like drainage patterns on Earth. But they were not carved by water. They were carved by methane rain. That was the moment Titan changed. It was no longer just a hidden moon. It became a place, a landscape, a world with ground you could imagine standing on. When Huygens finally landed, it touched down on a surface that looked like a frozen floodplain. Images showed rounded objects scattered across the ground, shaped almost like stones, but they were likely made of water ice. On Titan, ice can behave like rock. The surface was dim, orange, cold beyond human experience. But it was real. For the first time, humanity had landed on a moon in the outer solar system. And what it found was not a dead, simple ball of ice. It found a world shaped by atmosphere and liquid. Cassini continued the story from orbit. Because visible light could not see Titan's surface clearly, Cassini used radar and infrared instruments to look through the haze. And slowly, Titan's hidden geography was revealed. Huge dune fields near the equator, lakes and seas near the poles, mountain-like regions, river channels, possible cryovolcanic features, dark plains, bright terrains. Titan became one of the most Earth-like worlds we had ever studied, and one of the least Earth-like at the same time. That contradiction is what makes it so powerful. If you were falling toward Titan, you would not see a grey, airless moon beneath you. You would descend into atmosphere. You would pass through haze. Light would become softer. The sun would be weak, dimmed by distance and filtered through orange smog. The sky would not be black. It would glow amber. The surface would appear slowly, like something emerging from fog. And when you landed, the silence would be strange. Not the silence of vacuum. Titan has air, so sound could travel. But the world would still feel muted. The thick atmosphere, the cold, the distance from the sun, and the absence of life would create a silence unlike anything on Earth. You might see dark dunes stretching across the horizon, or flat plains covered in organic material, or icy stones shaped by ancient flow. If you landed near the poles, you might see the edge of a methane lake, a dark liquid sea under an orange sky. Waves might move slowly if the wind was right. Clouds might drift overhead. Rain might fall one day. But it would not be water. It would be methane, and you could not breathe. Titan's atmosphere may be thick, but it contains almost no oxygen. It is mostly nitrogen, like Earth's atmosphere, but without the oxygen that makes Earth's air alive for us. A human standing there without protection would suffocate. The cold would be deadly. The chemistry would be toxic. The surface pressure would not save you. Titan gives you atmosphere, but not life. This is why Titan feels more like a planet than a moon. It has complexity. It has climate. It has surface processes. It has a thick atmosphere that reshapes the world below. It has liquids moving across the surface. It has organic chemistry falling from the sky. It may even have a subsurface ocean beneath its icy crust. Titan is not just orbiting Saturn, it is running its own system, a frozen, alien version of planetary behavior. And that makes the question of landing there incredibly powerful, because landing on Titan would not feel like landing on the moon. It would not feel like Mars. It would feel like entering a place that almost understands what planets are. A world with a sky, a world with weather, a world with seas, a world where the ground, the air, and the liquid all interact, but every familiar thing would be changed. The air would not be breathable. The rain would not be water. The rocks would be ice. The rivers would be methane. The sunlight would be weak. The sky would be orange. And Saturn, the giant planet Titan orbits, might be hidden behind the haze. That may be one of the strangest details. You are standing on Saturn's largest moon, but you may not clearly see Saturn. The planet that controls Titan's orbit, tides, and place in the solar system might be concealed behind the thick orange atmosphere. A giant presence, invisible above you. This is the world we are about to enter, not just scientifically, but physically, sensory, emotionally. What would it feel like to descend through that haze? What would the light look like? What would the ground feel like beneath your boots? Would the air feel heavy against your suit? Would the low gravity make movement graceful? Would the silence feel peaceful or terrifying? That is the question driving this entire journey. Not only what Titan is, but what it would actually be like to be there, to fall through its orange sky, to touch down on its frozen surface, to stand beneath clouds made by alien chemistry, to look across a world that resembles Earth just enough to feel familiar and differs from Earth enough to feel impossible. Titan is not welcoming, but it is not simple. It is cold, dark, strange, and dangerous. Yet it is also one of the most fascinating places humans have ever discovered. A moon that behaves like a planet, a frozen world with liquid landscapes, a hidden place that waited centuries behind its haze, until we finally saw through it. And now that we have seen it, the next question becomes unavoidable. What would it feel like to land there? Before anyone could feel Titan's orange sky, they would first have to survive the distance. Because Titan is not close. It is not waiting beside Earth like the moon. It is not a neighboring world like Mars. Titan belongs to Saturn. And Saturn belongs to the deep outer solar system. That means the journey itself would be a test before the landing ever begins. A test of machines, a test of patience, a test of the human mind. From Earth, Titan's distance changes depending on where Earth and Saturn are in their orbits. But on average, Saturn is about 1.4 billion kilometers away. Titan orbits around Saturn, so reaching Titan means reaching the Saturn system. And with current technology, that kind of trip takes years, not months, years. The Cassini spacecraft took almost 7 years to reach Saturn after launch. A human mission using similar deep space travel methods would face a journey on that same scale. Around 7 years. 7 years inside a spacecraft. 7 years of recycled air. 7 years of artificial light. 7 years of scheduled exercise, system checks, delayed messages, emergency drills, and the same narrow corridors. Before the crew ever sees Titan's surface, Titan will already have changed them. The journey would begin with Earth falling away. At first, Earth would still look enormous through the windows. Blue. Bright. Alive. Clouds moving across oceans, the moon nearby, familiar and close. Then, slowly, Earth would shrink. The continents would disappear. The clouds would become white patterns. The oceans would become a blue glow. And then home would become a point, a bright dot in black space. That moment would be psychologically heavy, because every astronaut knows Earth is still there. But seeing it become small changes something inside the mind. It tells you that you are no longer simply traveling, you are leaving. The spacecraft would move outward through the solar system, following a carefully planned route. It might not fly in a straight line, because direct travel to Saturn requires enormous energy. Instead, it could use gravity assists, letting planets bend its path and increase its speed. The route would feel almost like a slow escape through layers of the solar system. First, the inner worlds, Earth behind, Mars ahead, a small red planet drifting in the darkness. If the spacecraft passed near Mars, it would not feel like arriving somewhere. It would feel like passing a checkpoint. Mars would appear as a red disk, a world humans dream of reaching. But for this mission, only a waypoint. Then the spacecraft would continue past the orbit of Mars into a colder, emptier region, the asteroid belt. From imagination, the asteroid belt sounds crowded like a dangerous field of tumbling rocks. But in reality, it is mostly empty space. The asteroids are separated by enormous distances. Still, the idea of moving through that region would carry its own tension. Somewhere out there are ancient fragments, rock and metal left over from the formation of the solar system, small worlds that never became planets. The crew might see nothing with their eyes, just darkness, but they would know they were crossing a region filled with history. Then comes Jupiter, the largest planet in the solar system, a giant so massive it changes the paths of objects around it. If the mission used a Jupiter gravity assist, this would be one of the most dramatic moments of the journey. After years of darkness, Jupiter would grow in the windows, first as a bright star, then as a disk, then as a world, bands of clouds, storms larger than Earth, the great red spot turning slowly, moons moving around it like a miniature solar system. For the crew, Jupiter would be both beautiful and intimidating, because it would remind them how deep they had gone and how much farther they still had to travel. After Jupiter, the sun would feel weaker. The spacecraft would move into colder territory. Solar panels, if used, would produce less power. The view outside would become darker. The mission would become quieter, more distant from everything human. The crew would be living not only in space, but in duration. Years passing in a metal habitat. Birthdays inside the same rooms. News from Earth arriving late. Family voices recorded and delayed. The psychological challenge would become one of the greatest parts of the mission. Because 7 years is not only a travel time, it is a piece of a life. People on Earth would change. Children would grow. Parents would age. Friends would move on. The astronauts would exist in a strange separation from normal time. They would be alive, working, thinking, speaking, but always delayed from Earth. At Saturn's distance, communication becomes painfully slow. A one-way signal can take around 80 minutes to travel between Earth and Saturn, depending on the positions of the planets. That means if the crew sends a message home, Earth may not hear it for more than an hour. If Earth replies immediately, the response may take another hour or more to return. A simple exchange could take nearly 3 hours. There would be no real-time conversation, no quick emotional support, no instant instruction from mission control. If something breaks, the crew must respond. If someone becomes sick, the crew must act. If the spacecraft detects a problem, waiting for Earth may not be possible. Mission control would still matter, but it would not be a voice in the room. It would be a distant partner, a slow echo from home. This kind of communication delay changes the psychology of spaceflight. The crew must become independent. They must trust each other. They must make decisions without asking permission every time. They must carry the mission inside the spacecraft, because Earth is no longer close enough to guide every moment. And after 7 years of this, Saturn finally appears. At first, it would be almost unreal. A pale golden point growing brighter, then a small oval, then, slowly, the rings would reveal themselves. Thin, flat, impossible. A structure so delicate from a distance, but wide enough to span hundreds of thousands of kilometers. The first clear sight of Saturn would be one of the most emotional moments in human exploration. After years of travel, the destination would no longer be a number. It would be there, hanging in the window, a giant planet with rings wrapped around it like a cosmic instrument. But the mission would not end at Saturn. Titan would still be waiting. At first, Titan might appear as a small orange dot near the planet. Not bright like an icy moon, not grey like a cratered rock. Orange, soft, covered. A moon with no visible surface. As the spacecraft approaches, Titan would grow larger. The orange haze would become more obvious. A smooth, glowing shell hiding everything below. Unlike the Moon or Mars, Titan does not immediately show its landscape from space. It conceals itself. The crew would look at it and know that beneath that atmosphere are dunes, plains, lakes, river channels, and frozen ground. But none of it would be easy to see. That would make the approach feel different. Mars gives you a surface from orbit. The Moon gives you craters. Titan gives you a veil. The spacecraft would prepare for entry. Systems would be checked again and again. Heat shield alignment, trajectory, communication, parachute systems, landing radar, atmospheric sensors, power, thermal control. Everything would need to work, because after 7 years of travel, the most dangerous minutes might still be ahead. Entering Titan's atmosphere would be the moment the journey changes from spaceflight into descent. For years, the spacecraft has moved through vacuum, silent, weightless, controlled. Then suddenly, atmosphere. Titan's air would begin pressing against the heat shield. At first, faintly, then harder. The spacecraft would slow. Friction would heat the shield. Plasma and glowing gas could form around the capsule. After years in the cold of deep space, the vehicle would be surrounded by heat, a violent entry into a frozen world. The contrast is strange. Titan's surface is unimaginably cold, but reaching it requires surviving fire. The capsule would shake. For the first time in years, the crew would feel strong forces again, acceleration pressing them into their seats, vibration through the structure, the sound of atmosphere against the outer shell. Not silence anymore, movement, pressure, entry. Titan's atmosphere is thick, which helps. Unlike landing on an airless moon, a spacecraft can use atmospheric drag to slow down. But thick atmosphere also means heat, turbulence and complexity. The entry must be precise. Too steep, and the heating becomes dangerous. Too shallow, and the spacecraft could skip or miss the landing zone. The descent would be planned with extreme care. Then comes the parachute. At the right altitude, the first parachute deploys. A violent pull, a sudden change. The capsule slows sharply. Then perhaps another parachute, larger, more stable. The descent becomes slower, gentler. Titan's thick atmosphere and low gravity make parachute landing unusually favorable compared to many worlds. In a way, Titan helps you land. Its atmosphere catches you. The crew would begin to fall through the haze, not drop like a stone, float, descending slowly through orange air. Outside, the sky would not be black. It would be amber. Thick layers of haze would scatter the weak sunlight. The sun itself might be only a pale glow. Saturn might be invisible, the surface still hidden. Below the capsule, instruments would begin mapping the terrain. Radar searching through haze, cameras adjusting to dim orange light, wind sensors reading the atmosphere. The first sounds of Titan would begin against the spacecraft. Not human sounds, not life, but wind, alien air flowing over the hull. After 7 years of mechanical hum and deep space silence, hearing Titan's atmosphere would be haunting. A soft vibration, a rush, a whisper from another world. It would mean the spacecraft is no longer just near Titan. It is inside Titan. The crew would be entering a place that has weather. A place with air thick enough to carry sound. A place where clouds can form and liquids can move on the surface. Through the windows, the orange glow might slowly darken and brighten as layers of haze pass by. The descent could last hours, depending on mission design. And with every minute, the crew gets closer to the ground, closer to the thing no human has ever touched. The surface would appear slowly, first as shadows, then shapes, dark regions, channels, maybe dunes, maybe flat plains, maybe the edge of a methane lake if the landing site were near the poles. The feeling would be impossible to compare with any previous mission. Not the Moon, not Mars, not even Ganymede. Titan has atmosphere. Titan has weather. Titan has liquid landscapes. It feels almost planetary, almost familiar, but wrong in every detail. The crew would know the air outside is thick but poisonous to them. They would know the ground may be water ice frozen as hard as stone. They would know the lakes if nearby are methane and ethane. They would know the cold outside would destroy an unprotected human. But emotionally, the world might still feel closer to Earth than any other moon, because it has a sky, and that sky would be moving around them. The parachute descent would be the first time humans truly feel Titan, not just as data, but as resistance, as wind, as color, as pressure, as a world pushing back against the spacecraft. The capsule would continue downward, slower, lower, the haze thinning near the ground, the landscape sharpening, the landing engines or final descent system preparing. After 7 years in transit, after crossing the inner solar system, passing Mars, the asteroid belt, Jupiter, and Saturn's rings, the crew would finally be seconds from Titan, and in that moment, everything before would feel like preparation. The launch, the years of isolation, the delayed voices from Earth, the shrinking sun, the first sight of Saturn, the orange haze growing closer, all of it leading to this. The moment the spacecraft enters the lower atmosphere, the wind outside, the parachute above, the frozen surface below, and the realization that after one of the longest journeys humans could ever attempt, the real experience is only beginning. Because landing on Titan is not the end of the story. It is the first time the moon becomes real. Not a point of light, not an image, not a mystery behind haze, but a world beneath you, waiting in orange silence. The first thing you would feel is not the surface, it is the atmosphere. Because Titan does not let you fall straight down into silence. It catches you, slows you, wraps itself around the spacecraft, and for the first time since leaving Earth, you would be entering a world with real air. Not breathable air, not safe air, but air thick enough to push back, thick enough to shake the capsule, thick enough to carry sound. Titan's atmosphere is one of the strangest things in the solar system. It is about 1.5 times thicker than Earth's atmosphere at the surface. That means as you descend, you are not dropping into a thin Martian sky or an airless lunar vacuum. You are sinking into something dense, heavy, orange, a world-sized fog made of nitrogen, methane, and complex organic haze. From above, Titan looks smooth and mysterious. Its surface is hidden beneath a golden-orange blanket. No mountains, no lakes, no rivers, no shorelines visible in ordinary light. Just haze, a moon refusing to show its face. But once the spacecraft begins entry, the haze is no longer a distant feature. It becomes the world around you. The capsule hits the upper atmosphere at high speed. The heat shield faces forward. The spacecraft begins to tremble as Titan's air grows thicker. For years, the journey has been silent and weightless. But now there is resistance, pressure, friction, sound. The outer shell heats as it cuts through the atmosphere. The heat of entry surrounds the capsule, even though the world below is colder than almost anywhere humans could imagine. That contrast is haunting. To reach a place where the ground is nearly minus 179 degrees Celsius, you must first pass through fire. The heat shield glows. The spacecraft slows. The forces build. Then, gradually, the violence begins to ease. Titan's thick atmosphere does something precious. It helps you land. On the moon, there is no air to slow you down. On Mars, the air is thin and difficult, but Titan's atmosphere is deep and dense. It gives parachutes something to grip. At the right moment, the first parachute deploys. The pull is sudden, a hard shift from entry to descent. The capsule slows dramatically, hanging now beneath fabric, falling through the orange sky. And this is where the experience changes completely. You are no longer a spacecraft crossing space. You are an object inside weather. The descent becomes slower, longer, more atmospheric in every sense. Outside the window there is no black sky. There is orange. Not bright orange like flame, more like dim amber. A permanent sunset. Sunlight has traveled all the way out to Saturn, already weak from distance, and then it has been filtered through Titan's thick haze. By the time it reaches you, it is soft, scattered, muted. The sun itself might not look like the sun. It may be only a pale glow hidden somewhere above the haze. The sky has depth, layers. Above you, darker orange. Below you, a dim world slowly forming through mist. At first, you see nothing clearly, just color. a thick fog of organic particles suspended in nitrogen-rich air. The atmosphere around you is mostly nitrogen, like Earth's atmosphere, but that similarity is deceptive. Earth's nitrogen atmosphere also contains oxygen. Titan's does not, at least not in any way humans could use. You could not breathe this air. Your lungs would find no life in it. It is thick enough to feel real, but completely unable to keep you alive. And mixed into that nitrogen is methane. Methane in the air, methane in the clouds, methane in the weather. On Earth, methane is a gas associated with fuel and chemistry. On Titan, methane behaves more like water does here. It evaporates, condenses, forms clouds, falls as rain, gathers in channels, and fills lakes and seas. As the capsule continues downward, the atmosphere becomes more than a visual experience. It becomes audible. We know this because of Huygens. In 2005, the Huygens probe descended through Titan's atmosphere and became the first spacecraft ever to land on a world in the outer solar system. It gave humanity our only real direct reference for what this descent is like. Huygens did not just take images, it measured the atmosphere, it studied the wind, it listened. During descent, instruments recorded sounds and acoustic data from Titan's air, the rush of wind against the probe, the motion of the atmosphere around it, the living texture of a world that was not silent vacuum. That detail matters because Titan is one of the few places beyond Earth where wind could truly be heard. Not imagined, not simulated, heard. If you were descending inside a crude capsule, you might hear the faint vibration of wind against the hull, a low, alien rushing sound, softer than a storm on Earth perhaps, but unmistakable. Air moving, a moon speaking in pressure and turbulence. After years in deep space, that sound would feel almost emotional. The spacecraft has been surrounded by emptiness for so long. No wind, no weather, no atmosphere pressing against it. Then Titan begins to make noise. The descent continues. The parachute stabilizes the capsule. Instruments begin scanning below. Radar looks through the haze. Cameras adjust to the dim light. Atmospheric sensors read pressure, temperature, methane concentration, wind speed. The temperature drops as you descend. Layer by layer, Titan gets colder. The upper atmosphere may be cold, but the surface is brutally colder still. By the time you approach the ground, the temperature is around minus 179 degrees Celsius. That is not cold like Earth cold. That is a temperature where water ice becomes rock, where metal and machinery must be protected, where every seal, cable, battery, and moving part must be designed for survival. Outside, the air is thick, but it is freezing. This is one of Titan's contradictions. The atmosphere feels planet-like. The sky feels real. The descent feels almost Earth-like compared to landing on airless moons. But the chemistry and temperature are completely alien. And then, during descent, something even stranger may happen. Rain. Not water rain, methane rain. Dark droplets falling through orange air. Slowly perhaps, because Titan's gravity is weak and its atmosphere is thick. Rain on Titan may fall differently than rain on Earth. Gentler, larger drops, slower motion. Alien weather moving through a dense, cold sky. Imagine seeing streaks against the window. A world with rain. A moon where liquid falls from clouds. For a moment, the mind wants to understand it as familiar, but it is not. Those drops are not water. They are methane, the kind of substance that on Earth we treat as gas and fuel, falling here as weather. That is what makes Titan so unsettling. It gives you Earth-like sensations with non-Earth materials. Clouds, rain, wind, rivers, lakes. But every ingredient is wrong for us. As the capsule sinks lower, the haze begins to thin, not disappear completely, but shift. The orange veil starts to reveal shapes. At first, the surface is only shadow, dark patches, light patches, blurry boundaries. Then patterns begin to form. Long channels, branching lines, areas that look like drainage systems, the kind of shapes you would expect to see from above a river valley on Earth. But these rivers were not carved by water. They were carved by liquid methane and ethane, moving across a surface made largely of water ice and organic material. The landscape slowly becomes real. The first clear shapes might be dunes, long dark fields of organic sand, formed by particles falling from the atmosphere and shaped by Titan's winds. Or you might see bright highlands, icy and eroded, or flat plains, darkened by organic material. If the descent is near the poles, the view could become even more extraordinary. A shoreline appears, not an ocean of water, a methane sea. Dark, smooth, alien. Titan has large hydrocarbon seas near its poles, such as Krakenmare and Ligea Mare. From above, they would look like dark shapes against the land, almost black compared to the surrounding terrain. A sea on another moon, liquid lying open under an orange sky. That sight alone would be one of the greatest moments in human exploration. Because liquid surfaces are rare. Earth has them. Titan has them. Almost nowhere else does. As the spacecraft descends toward a landing site near one of these regions, the shoreline may sharpen. You might see channels feeding into the sea, curving edges, dark basins, possible islands, smooth surfaces reflecting dim light. It would look almost familiar. A coast, a place where land meets liquid, but the temperature outside is nearly minus 179 degrees Celsius. The liquid is methane and ethane. The air is nitrogen and hydrocarbon haze, and the ground is frozen harder than stone. The capsule continues downward. The parachute sways gently in Titan's winds. The landing system corrects position. Radar altitude counts down. The surface becomes clearer with each minute. The orange haze that hid Titan for centuries is no longer hiding everything. You are beneath it now, inside it, seeing what astronomers could not see for generations. The same kind of revelation Huygens experienced in 2005, when Titan's surface slowly appeared beneath the probe. Those Huygens images were not sharp by modern standards, but they changed everything. They showed branching channels, bright terrain, dark plains, and finally a surface scattered with rounded ice pebbles. They proved that Titan was not just a featureless orange ball. It was a world, and for a crew descending through the same atmosphere, that realization would become physical. The moon below is no longer theory. It is rising toward you. The lower you fall, the more the atmosphere feels like a place. The air presses around the vehicle. The wind moves it slightly. The parachute responds. The ground gains texture. You might see dark riverbeds cutting across icy terrain. You might see smooth plains where liquids once flowed. You might see dunes stretching like black waves. You might see the edge of a methane lake. still and silent under the orange sky. And then comes the final moment. The haze clears enough for the surface to fully reveal itself, no longer blurred, no longer hidden, no longer a mystery behind atmosphere. The landing site appears, a frozen plain, a dark organic desert, a river delta, a shore beside a methane sea. Whatever the exact place, the emotional impact would be the same. After years of travel, after passing through Saturn's system, after entering the orange veil, you finally see Titan as a world beneath you. The parachute lines stretch above. The capsule hangs in dense alien air. The wind whispers against the hull. The ground comes closer, and for the first time, you understand what makes Titan different from every other moon. It does not simply wait in space. It receives you. It surrounds you. It lets you fall slowly through its atmosphere, as if giving you time to realize where you are. A moon with a sky, a moon with weather, a moon with rivers and lakes made from alien chemistry. And as the surface finally becomes clear, the descent ends. But the feeling of Titan has only just begun. Touchdown on Titan would not feel violent, not like crashing into a dead rock, not like slamming onto an airless moon. It would feel strangely soft, slow, almost gentle. After the fire of atmospheric entry, after the parachute descent through orange haze, after the long fall through a sky thicker than Earth's, the surface would finally rise. Beneath you, not sharp mountains, not jagged cliffs, not a field of broken stone, but something surprisingly flat, smooth, muted, a frozen plain under an orange sky. The lander would descend through the final meters, its instruments reading altitude, wind speed, surface slope, temperature, pressure, and chemical composition. Then, for the first time, human technology touches Titan. The legs compress, the ground resists, a dull vibration moves through the spacecraft. And then, stillness, touchdown. You have landed on Saturn's largest moon. But the world outside does not look like any place humans have ever known. The first thing you might notice is the color. There is no blue sky, no black sky either, no familiar daylight. Above the lander is a thick orange atmosphere, glowing like a permanent sunset. The haze is everywhere. It fills the sky. It softens the horizon. It makes distance feel uncertain. On Earth, the sky can feel open, infinite, transparent. On Titan, the sky feels heavy, closed, as if the whole moon is wrapped in amber glass. The sun is there, but barely. At Saturn's distance, sunlight is almost 100 times weaker than what Earth receives, and after passing through Titan's thick haze, it becomes even dimmer. The sun would not dominate the sky as it does on Earth. It would look more like a bright star, a pale glow hidden behind orange fog, enough to create daylight, but not warmth, not comfort, not life. The light would feel weak and ancient, as if the sun itself had become distant memory. And Saturn, the giant planet Titan orbits, would not hang clearly in the sky the way we might imagine. That may be one of the strangest disappointments. You are standing on a moon of Saturn. Saturn is nearby by cosmic standards. Its rings are out there. Its golden body is out there. But Titan's haze hides so much. Through the atmosphere, Saturn might appear only as a faint disk, a vague shape, a ghost behind the orange sky, sometimes maybe invisible. Not a bright ringed giant overhead, but a hidden presence, something huge controlling the world, without fully revealing itself. Beneath the lander, the ground is not ordinary rock. Titan's surface is made largely of water ice, but at Titan's temperature, water ice does not behave like the ice in your freezer. It is not soft. It is not fragile. It is stone hard. On Titan, water ice becomes geology. Mountains, pebbles, plains, and crust can be made of frozen water as solid as rock. The lander may come down on rounded icy pebbles, shaped over time by flowing methane and ethane. That detail is almost impossible to fully accept. Pebbles rounded by rivers, on a moon where water cannot flow. The rivers are methane, the stones are ice. The landscape is familiar in shape, but alien in substance. If the lander's footpads press into the surface, there may be a crunch. Not the crunch of snow, not the dry crack of earth gravel. Something duller, colder, a brittle compression of frozen grains and ice pebbles beneath metal. The surface might give slightly. Hygiens found a ground that seems somewhat soft at landing, possibly like wet sand or clay-like material, but made from alien chemistry and frozen compounds, so Titan's surface could feel firm, but not perfectly hard. A crust, a packed layer, organic material mixed with ice grains, hydrocarbon dust fallen from the sky over millions of years, a dark, frozen, chemical soil. You would not step onto grey dust like the moon. You would not step onto red powder like Mars. You would step onto a world covered in organic haze material, icy grains, and frozen landscapes carved by methane weather. The ground might be dark brown, orange-black, or charcoal-like. Not glowing, not colourful in a bright way. More like a dim oil-stained desert under amber light. And all around, the wind would move. Titan is not silent like an airless moon. It has atmosphere, real atmosphere, dense enough to carry sound, dense enough to push against a lander, dense enough to move sand dunes across the surface. The wind near the ground might be gentle, perhaps around 5 meters per second. Not a violent storm, not enough to knock over a strong lander, but constant, persistent, a slow alien movement through nitrogen-rich air. You would hear it through the structure, a low vibration, a soft pressure against the hull. If microphones were outside, they might capture a muted rushing sound, wind passing over metal, particles tapping faintly, the atmosphere breathing across the frozen plain. And if methane drizzle were falling, there might be another sound. Tiny impacts, soft ticking, liquid methane touching the lander, the surface, the instruments. Rain on Titan would not fall exactly like rain on Earth, because Titan's gravity is weak, and its atmosphere is thick. Droplets could fall more slowly, more gently, almost dreamlike. Imagine standing inside the lander, listening to methane drizzle on the outside shell. Not water, not life-giving rain, but alien rain. Cold hydrocarbon liquid falling from orange clouds onto ice-hard ground. It would be one of the most haunting sounds in the solar system. Wind, methane drizzle, mechanical hum, and beyond that, silence. Not the silence of vacuum, something stranger, a world with air, but no birds, no insects, no leaves, no ocean waves like Earth, no human-made background noise, just atmosphere moving over a dead-cold landscape. Titan would have sound, but almost no life to create it. If you could smell the air, which you could not safely do. It might smell chemical, thick, hydrocarbon rich, maybe something like gasoline, natural gas, tar, solvents, or strange organic haze. But this is only imagination. You would never open your helmet. You would never breathe Titan's air. Its atmosphere is mostly nitrogen, with methane and other hydrocarbons, but no breathable oxygen. To smell Titan directly would mean exposing yourself to an environment that cannot support human life. So the smell of Titan would remain forever unreachable. A world with an atmosphere, but one you can never inhale. That might be one of the most emotional parts of being there. Titan seems close to familiar. It has air, weather, wind, rain, a horizon, maybe shorelines, maybe clouds. But every familiar thing refuses. You can see the sky, but not breathe it. You can hear the wind, but not feel it on your skin. You can watch rain fall, but it is not water. You can stand near a lake, but it is methane. Titan gives the shape of Earth, without the permission of Earth. Then comes gravity. Titan's gravity is only about 14% of Earth's, almost the same as Ganymede. That means your body would feel incredibly light. A person who weighs 70 kilograms on Earth would feel as if they weighed around 10 kilograms on Titan. Inside a suit, movement would be strange. The suit would still have mass. Tools would still resist motion. A backpack life support system would still be bulky. But the pull downward would be weak. Each step could carry you farther than expected. You would need to move carefully, slowly. A small push could shift your balance. A jump could lift you gently into the air. And because Titan's atmosphere is so thick, movement might feel even stranger. You would be light, but surrounded by dense air. In theory, with wings attached to your arms, a human might even be able to glide or fly in Titan's low gravity and thick atmosphere. That idea sounds like fantasy, but physically, Titan is one of the few worlds where the atmosphere and gravity create that possibility. Still, on the surface, wearing a survival suit, you would not feel free. You would feel cautious. Every movement would be controlled. Every step measured, because falling on Titan might happen slowly, but damaging a suit would be dangerous. The first step outside would be unforgettable. The airlock opens, the orange light enters, you move down the ladder, your boot touches the surface, a faint crunch beneath you, frozen grains shifting, the ground of another world accepting your weight. And then you stand. For a moment you might not move, you might simply look. The horizon is close and soft because the haze hides distance. The sky is on, the ground is dark, the sun is weak, Saturn is barely visible, maybe only a pale blur above the atmosphere. The lander behind you glows with artificial lights, and in front of you is Titan, not an image, not a radar map, not a mystery behind haze, a place, a real place. There may be dunes in the distance, long dark waves of organic sand, or rounded icy stones scattered across a flat plain, or channels carved by methane floods, or, if the landing site is near the poles, the dark edge of a methane sea. A shoreline on another moon. That would be almost too much to process, because your brain would keep trying to compare it to Earth. A beach, a desert, a foggy valley, a cold coastline. But none of those comparisons would be correct. Titan would look familiar enough to disturb you, and alien enough to remind you that you are very far from home. The emotional overwhelm would not come all at once. At first, training takes over. check pressure, check temperature, check suit status, confirm communication, inspect lander, read instruments, report surface conditions. But then between tasks, reality would break through. You are standing on Titan, more than 1 billion kilometers from Earth, under an orange sky, on ground shaped by methane rivers, with Saturn hidden above you. No human has ever stood this far from home. No human has ever heard wind on this moon. No human has ever watched methane weather fall around them. And suddenly, the place becomes more than science. It becomes personal. The cold outside is absolute. The atmosphere is poisonous. The landscape is empty. But it is beautiful. Not beautiful like Earth. Not warm. Not welcoming. Beautiful in the way impossible things are beautiful. Because Titan should not feel so familiar. And yet it does. A moon with weather. A moon with liquid. A moon with a sky. A world that almost invites you closer, while reminding you that you can never belong to it naturally. That is what landing on Titan would actually feel like. A soft touchdown on frozen ground. A crunch beneath the lander. Orange light everywhere. Wind moving through alien air. Methane drizzle ticking faintly against metal. A weak sun hidden above. Saturn barely visible through haze. Your body light under Titan's gravity. Your mind heavy with distance and all around you. A world that looks like Earth's dream. After the universe changed the rules. Standing on Titan would feel like standing inside a memory of Earth, but a memory that has been rewritten by another universe. At first, your mind would try to understand the landscape using familiar words. Sky, ground, wind, rain, rivers, lakes, mountains, shorelines. All of those things exist on Titan. And that is what makes it so unsettling. Because the shapes are familiar, but the ingredients are wrong. The sky above you is not blue. It is orange, thick, hazy and glowing softly with weak sunlight filtered through layers of organic smog. There is no sharp brightness, no clear horizon line the way you might see in a dry desert on Earth. Everything is softened by atmosphere. The world feels dim. Not dark exactly, but muted, as if you are standing inside an endless sunset that never becomes night and never becomes day. The ground beneath your boots stretches outward in flat plains, not soft soil, not sand in the ordinary sense, not rock like Earth's stone. Much of Titan's surface is made of water ice. But at Titan's temperature, water ice is as hard as rock. The pebbles beneath you could be rounded pieces of frozen water, shaped by ancient flows of liquid methane and ethane. That is one of the strangest things about the landscape. The stones may be ice. The rivers may be methane. The rain may be hydrocarbons. And the mud may be dark organic material fallen from the sky. If you looked around near a place like the Hygien's landing site, the surface might appear like a frozen floodplain. Flat, dark, scattered with rounded objects. The Hygien's probe showed us a ground covered with pebble-like shapes, almost like river stones on Earth. They looked familiar because flowing liquid had shaped them. But they were not ordinary stone. On Titan, water is the rock. Methane is the liquid. The landscape is a chemical inversion of Earth. And that inversion would follow you everywhere. In the distance, The plains might stretch toward a hazy horizon that appears closer than Earth's. Titan is smaller than Earth, so its curvature is stronger. The world bends away sooner. Combined with the orange haze, this would make the horizon feel strangely near, almost enclosed. You would not feel like you were standing beneath an open sky. You would feel like you were inside Titan's atmosphere, wrapped in it, surrounded. The colors would be limited but beautiful. Orange, brown, gold, black, amber, dark bronze. No green forests, no blue oceans, no white clouds like Earth. Everything is filtered through the same alien palette. The sky glows orange. The surface appears brownish and dark. The dunes in the distance may look almost black. The lakes, if nearby, could reflect the orange sky like dark mirrors. A methane lake on Titan would not look like a sparkling blue lake on Earth. It would likely appear dark, smooth, almost oily, a black liquid surface under a golden sky. If the wind moved across it, tiny waves might ripple slowly. Not dramatic ocean waves, something quieter. Lower gravity and different liquid properties would make the motion feel unfamiliar. A shoreline on Titan would be one of the most haunting sights in the solar system. Land meeting liquid, just like Earth. But the liquid is methane and ethane, so cold that water becomes stone beside it. You might see channels leading into the lake, branching like river deltas. You might see dark stains where liquid once flowed. You might see smooth plains where floods spread across the ground and then retreated. The scene would almost make sense. That is the dangerous part. Your brain would say, coast, river, rain, beach, but every word would be wrong. Farther away, dune fields might rise from the plains. Titan has vast fields of dark dunes, especially near the equator. These dunes are not made of ordinary silica sand like many deserts on Earth. They are likely made of organic particles, complex carbon-rich material created in the atmosphere and slowly falling down over time. Imagine particles forming high above you in orange haze. Tiny grains of organic material drifting downward for thousands, millions, maybe billions of years. They settle on the surface. The wind gathers them, pushes them, shapes them into long, dark dunes. From where you stand, they might look like black waves frozen across the landscape. A desert made from the chemistry of the sky. And beyond the dunes, mountains may rise. Not huge like the Himalayas, not sharp like young volcanic peaks, but ridges and highlands made of water ice, lifted and shaped by Titan's internal geology. They would appear softened by haze, their outlines blurred in the orange distance. Mountains of ice, hard as rock, standing under a sky of methane weather. This is why Titan feels more like a planet than a moon. The landscape is not random. It has systems. Weather changes the ground. Liquids carve valleys. Winds build dunes. Rain falls from clouds. Lakes fill and evaporate. The surface is active in a slow, cold, alien way. Titan has its own version of Earth's water cycle, but instead of water evaporating from oceans, forming clouds, falling as rain, and flowing through rivers, Titan uses methane. Methane evaporates from lakes and seas. It rises into the atmosphere. It forms clouds. It falls as rain. It carves channels. It returns to lakes. A methane cycle, a cold mirror of Earth's hydrological system. And if you were standing there during rainfall, the experience would be unforgettable. Rain on Titan would not fall the way rain falls on Earth. Titan's gravity is weak, only about 14% of Earth's. Its atmosphere is thick. That means droplets could fall more slowly, almost gently, as if time itself had softened. The drops might also be larger than typical Earth raindrops, larger droplets, falling slower through orange air. Imagine watching methane rain descend from the haze in slow motion. Dark droplets drifting downward, tapping against the lander, touching the frozen ground, collecting in shallow depressions, running slowly into channels carved over ancient time. It would be beautiful and completely lethal to touch without protection. That is Titan's strange emotional power. It gives you scenes that feel peaceful, but nothing there is safe. Even the soundscape would be eerie. Titan has a thick enough atmosphere to carry sound. You could hear wind against the lander. You could hear particles moving. You might hear methane drizzle against the surface or the faint patter of liquid on metal, but there would be no biological noise. No birds, no insects, no leaves, no flowing water as we know it. Just alien weather over a frozen world. Wind, drizzle, mechanical breathing from your suit, and silence between them. The wind itself might be gentle, but persistent. It would move through the haze, shaping dunes over long periods. It might not roar like a storm on Earth, but because the atmosphere is dense, even moderate winds could push against structures and carry fine organic particles. In the distance, you might see haze shifting over the plains. The landscape would fade quickly. Objects far away would lose sharpness. Mountains would become silhouettes. Dunes would become dark bands. A methane lake would merge with the orange-brown horizon like a shadow. And above, clouds could form. Titan's clouds are not like Earth's water clouds. They are methane clouds. They can gather, thicken, and release rain. Some scientists have considered whether lightning could occur in Titan's atmosphere, especially in methane-rich storm systems. We do not know how common it would be, or whether it happens in a way easily visible from the surface. But imagine the possibility. A dim flash hidden inside the orange haze. Not bright blue-white lightning across a summer sky, but a muted glow, a brief illumination inside alien clouds. For a moment, the sky brightens. The dunes sharpen. The methane lake reflects a faint pulse. Then the world returns to amber darkness. That possibility alone makes Titan feel alive in a strange way. Not alive biologically, but active. A world with atmosphere doing things. Moving, changing, hiding, revealing. The Huygens landing site gave us our first and only direct look at Titan's ground. And what it showed was not dramatic in the Hollywood sense. It was not towering cliffs or glowing alien forests. It was something quieter. A flat, dim landscape. Rounded, icy pebbles. A surface that looked washed, shaped, and weathered. That quietness is what made it powerful, because it looked real. It looked like somewhere you could almost imagine walking. Almost. And that almost is what makes Titan so haunting. If you stood there in a suit, you might feel emotionally confused. Part of you would recognize the world, the horizon, the haze, the possibility of rain, the smooth stones. the channels, the lakes. But another part of you would know you are standing more than 1 billion kilometers from Earth, on a moon where the ground is frozen water, the rivers are methane, and the sky is permanently orange. You might look down and see your boot pressed into dark organic material. You might see tiny grains sticking to the suit. You might see frozen pebbles scattered like river stones. You might look up and see no blue anywhere, no familiar sun, only a pale glow above the haze. Saturn itself may be hidden, a giant planet nearby, controlling Titan's orbit, but concealed by the atmosphere. The world feels enclosed, dreamlike, as if the sky is a ceiling. If you landed near a methane sea, the emotional effect would be even stronger. A shoreline means something ancient to humans. It suggests movement, travel, reflection, possibility. But on Titan, the sea would be dark and cold. It would not invite you. It would warn you. A black mirror of liquid hydrocarbons lying under an orange sky. The waves, if present, would move slowly. The shore might be made of icy grains, organic sludge, or frozen material shaped by changing liquid levels. There could be river channels nearby, feeding into the sea after methane rainfall. There could be smooth plains where liquid once covered the ground. There could be layers of dark sediment, built from chemistry falling out of the sky. Everything around you would tell the story of a world that has weathered itself, not with water, but with methane. And that is the central wonder of Titan's landscape. It mirrors Earth, but it refuses to become Earth. It has rain, but not water. Lakes, but not oceans we could swim in. Rivers, but not life-giving streams. Mountains, but made of ice. Sand, but made of organics. Air, but no oxygen. Light, but almost no warmth. Beauty, but no welcome. Standing there, you would understand why Titan is one of the most important worlds ever explored. Not because it is comfortable, not because it is safe, but because it shows that Earth-like processes can happen in completely alien conditions. A world does not need liquid water on the surface to have rivers. It does not need blue skies to have weather. It does not need warmth to have landscapes shaped by flowing liquid. Titan expands the imagination. It proves that nature can repeat patterns with different materials. It can build a coastline from methane, a desert from organic haze, a mountain from frozen water, a sky from nitrogen and smog. And the result is eerie, but beautiful. A world of orange-brown silence, flat plains stretching toward a close horizon, dark dunes in the distance, ice mountains softened by haze, methane rivers cut into frozen ground, slow rain falling through thick air, a black lake reflecting an amber sky, and you standing there, light under Titan's weak gravity, listening to alien wind move across a moon that looks almost familiar, but will never belong to us. A sea on Titan would look wrong before you understood why. From a distance it might seem almost familiar. A dark shoreline, a flat liquid surface, a horizon softened by haze, a sky glowing orange above it. For a moment your brain might reach for Earth, a cold lake, a northern coast, a quiet sea under winter light. But then you would remember where you are. This is not Earth. And that liquid is not water. It is methane. Titan has something almost no other world has. Open liquid on its surface, not frozen beneath ice, not hidden deep below, not trapped as vapor in an atmosphere, but lying openly across the ground, in lakes and seas, near Titan's poles, especially the north. Enormous dark bodies of liquid-filled basins carved into the frozen landscape. The three greatest are Kraken Mare, Ligeia Mare, and Punga Mare. They are not small ponds, they are seas, alien seas, and the largest of them, Kraken Mare, is so vast that it may be larger than Earth's Caspian Sea, a sea of methane and ethane on a moon of Saturn. Imagine standing at the shore. Behind you, dark icy plains stretch into orange haze. In front of you, the liquid begins, smooth, black, reflective. It does not sparkle blue like Earth's oceans. It does not glow with sunlight. The sun is too weak here. The sky is too thick. Instead, Kraken Mare would look like a dark mirror under an amber sky, a surface of liquid hydrocarbons, so cold that water itself would be frozen solid around it. The shoreline might be made of icy grains, organic sediment, and frozen material shaped by changing liquid levels. There may be rounded pieces of water ice lying like stones. There may be dark deposits left behind as methane evaporates. There may be channels feeding into the sea, carved by rainfall and ancient flows. It would look like a coast, but every part of it would be chemically alien. The liquid itself might be transparent in some conditions, almost like water. But it is not water. It is a mixture of methane, ethane, nitrogen, and dissolved organic compounds, cold beyond anything we normally associate with liquid, around minus 179 degrees Celsius. On Earth, methane is a gas. On Titan, it behaves like rain, river, lake, and sea. That is what makes Titan so strange. It has a liquid cycle, a weather system, a surface shaped by flowing material. But the material is different. Earth has water. Titan has methane. The waves would not look like Earth's waves. Titan's gravity is weak, its atmosphere is thick, its winds near the surface are often gentle. Because of this, waves on methane seas may be small, subtle, slow, maybe only ripples most of the time, a soft movement across the dark surface. Not crashing surf, not roaring waves, just a quiet shifting of liquid under orange light. If you stood there in a protective suit, you might hear almost nothing. A low wind moving across the shore, a faint sound of methane drizzle if rain were falling, maybe tiny liquid movements against icy ground, and then silence. Not the silence of vacuum. Titan has air, sound can travel, but there is no life-filled noise, no birds over the sea, no insects near the shore, no trees moving in the wind, only alien weather, and the faint mechanical sound of your own suit keeping you alive. Falling into one of Titan's methane seas would be catastrophic, not because the sea is hot or violent, but because it is unimaginably cold. The liquid would attack the suit thermally, pulling heat away from the outside layers. Any weakness in insulation, sealing, pressure systems, or mobility could quickly become dangerous. You could not swim naturally. Your suit would be bulky. The gravity would be weak. The liquid would behave differently from water. And if the suit were damaged, the environment would become deadly. The methane sea is not something humans could touch. Not with skin, not with lungs, not with ordinary equipment. It is a liquid landscape that looks inviting only because the human mind associates lakes with life. On Titan, the sea is beautiful, but it does not welcome you. And yet, scientifically, those seas may be some of the most fascinating places in the solar system, because Titan's atmosphere is a chemical factory. High above the surface, sunlight and particles from Saturn's environment break apart nitrogen and methane. Those fragments recombine into more complex organic molecules. Over time, they form haze, particles, dark material, and slowly they fall down through the orange atmosphere onto the ground, into rivers, into lakes, into seas. That means Titan seas may contain a rich mixture of organic compounds, not life necessarily, but chemistry, carbon-based material, molecules that may interact, dissolve, separate, sink, float, and accumulate over time. Kraken Mare is not just a body of liquid. It may be a chemical archive, a place where atmospheric chemistry collects for millions of years, a dark basin storing the products of Titan's sky. Could anything live there? That is one of the strangest questions we can ask. Life as we know it needs liquid water. Titan's surface seas are not water. They are methane and ethane. They are extremely cold. Chemistry moves slowly at those temperatures. Cell membranes, proteins, and water-based biology like ours would not work there. So if life exists in Titan's surface lakes, it would not be Earth-like. It would need a completely different chemistry, a biology based on hydrocarbons instead of water, something adapted to cold liquid methane, something so different that we might not recognize it at first. Scientists have imagined this possibility, not because we know it exists, but because Titan forces us to ask whether life has more than one way to happen. Could chemistry organize itself in methane? Could molecules form stable structures? Could energy flow through a system slowly enough to sustain something? We do not know. But Titan makes the question feel real, because the liquid is there. The organic compounds are there. The environment is stable over long periods, and sometimes in science, a place becomes important not because it gives answers immediately, but because it asks questions we never thought to ask. The shoreline may be especially interesting. On Earth, shorelines are rich environments, places where water, land, atmosphere, sunlight, and chemistry meet. Titan's shorelines are not alive like Earth's. There are no plants growing at the edge, no algae, no reeds, no shells, no animals. But chemically, the edge of a methane sea could still matter. It is a boundary zone. Liquid meets solid ground. Organic particles collect. Evaporation may leave deposits. Rainfall may wash material from the land into the sea. Changing liquid levels may create layered sediments. If any unusual chemistry happens on Titan's surface, shorelines could be one of the best places to search. Not for forests, not for visible life, but for patterns, deposits, structures, chemical gradients, the fingerprints of processes we do not fully understand. Maybe nothing grows there. Maybe the shore is only dark sediment and frozen ice. But even that would be valuable, because it would show us how complex organic chemistry behaves on a world with weather, liquid, and time. This is why future mission concepts have imagined exploring Titan seas directly, not only from orbit, not only from the air, but by floating on them or diving beneath them. A submarine in Kraken Mare sounds like science fiction, but it has been seriously studied as a future concept. A robotic submarine could descend into the methane sea and measure its depth, temperature, composition, currents, and seabed. It could listen, Map, sample, explore a sea on another world. Imagine that. A submarine not in Earth's ocean, but in a sea of liquid methane under Titan's orange sky. Its lights moving through dark hydrocarbon liquid, its instruments scanning the unknown. Below it, the floor of Kraken Mare. What would be there? Layers of organic sediment, ice rocks, chemical deposits, strange slush-like mixtures, evidence of seasonal changes, material washed down by methane rivers. The floor of Kraken Mare could preserve Titan's history. Storms, rainfall, erosion, atmospheric chemistry, maybe even clues about whether the sea connects to deeper reservoirs below. We do not know. That is the point. No one has ever seen the bottom of an alien sea. Standing at the shore, you would feel that mystery physically. The sea would not move much. It would lie there quietly, dark and cold, almost perfectly still. But beneath that stillness could be layers of chemistry accumulated across unimaginable time. Every drop of methane rain that fell from the sky, every particle of organic haze that settled from the atmosphere, every river channel that carried material into the basin, all of it eventually becomes part of the sea. Titan's seas are not empty. They are slow chemical worlds. And emotionally, the sight would be overwhelming. Because humans understand shorelines deeply. A shoreline is one of the most ancient landscapes in our memory. It means travel, danger, food, reflection, unknown horizons. On Earth, standing at the edge of the sea connects us to something alive and moving. On Titan, standing at the edge of Kraken Mare would connect us to something colder, older, stranger. A sea with no fish, no saltwater smell, no crashing waves, no blue sky, only methane, orange haze, frozen ground, and Saturn hidden somewhere above. It would feel peaceful, but not comforting. Beautiful, but not safe. Familiar, but impossible. That is the power of Titan. It gives us Earth-like scenes with alien chemistry. A coast without water, rain without warmth, lakes without life as we know it. A sea under a sky that has never been blue. And if one day a lander, a drone, or a submarine reaches the edge of Kraken Mare, it may show us one of the most haunting views ever captured. A dark alien ocean, a shoreline made of frozen chemistry, a world where nature repeated the shape of Earth, but wrote it in methane instead of water. And standing there, even through a suit, even behind glass, even through instruments, you would understand something profound. Titan is not Earth, but it proves that Earth is not the only world that knows how to make seas. Surviving on Titan would be strange because, in one important way, Titan is easier than most worlds. It has air, real air, a thick atmosphere pressing against the surface, not like the Moon, not like Mars, not like the vacuum around icy moons such as Europa or Ganymede. On Titan, you would not step outside into empty space. You would step into atmosphere. Dense, orange, cold atmosphere. And that single fact changes everything. But it does not make Titan safe. It only makes it dangerous in a different way. Because Titan's atmosphere can surround you, but it cannot save you. It is mostly nitrogen, with methane and other hydrocarbons mixed into it. In that sense, Titan's air is not violently corrosive or instantly poisonous in the way some alien atmospheres might be imagined. The problem is simpler. There is no oxygen for you to breathe. A human standing on Titan without breathing equipment would not be crushed by vacuum. They would not need a pressure suit in the same way astronauts do on the moon. But they would still suffocate. The air is thick, but it is useless to human lungs. That is one of Titan's strangest contradictions. You would be surrounded by atmosphere and still need to bring your own air. A suit on Titan would not be primarily about pressure. It would be about oxygen and heat, especially heat, because Titan's surface temperature is around minus 179 degrees Celsius. That is the real killer. Not the pressure, not the atmosphere, the cold. At that temperature, the environment would attack every part of your equipment. Batteries would weaken, seals would stiffen, metals and plastics would behave differently. Moving joints could freeze if not protected. Electronics would need constant thermal control, and your body, without insulation and heating, could not survive. So a Titan suit would be very different from a classic spacesuit. It would not need to hold pressure against vacuum as aggressively as a moon suit. Titan's atmospheric pressure is actually higher than Earth's sea level pressure, so the outside environment already presses around the suit. But the suit would need to isolate you from the cold. It would need thick insulation, heated layers, a breathing system, a helmet sealed from Titan's air, carbon dioxide removal, moisture control, communication, navigation, medical monitoring, and enough power to keep all of it running. In some ways, it would be closer to an extreme deep diving suit combined with a polar survival suit and a spacecraft life support system. You could imagine a human walking on Titan wearing something bulky, heavily insulated, and heated from within. The suit would carry oxygen tanks or connect to a rover or habitat through refill systems. It would circulate warm fluid around the body, especially through the hands, feet, chest, and helmet, because if the heating system failed, the danger would begin quickly. Not instantly like vacuum, but relentlessly. The cold would start entering. Fingers and toes would lose warmth first. Joints would stiffen. The suit's outer systems could freeze, and every minute would become more dangerous. On Titan, heat is life. The suit would not simply protect you. It would create a small, moving climate around your body. A private Earth-like bubble inside orange alien air, and yet walking there might feel surprisingly manageable. Titan's gravity is only about 14% of Earth's. That means everything would feel much lighter. A heavy backpack, oxygen system, heater, batteries, tools, and protective layers would still have mass. They would still resist movement. You would still feel their inertia when turning, stopping, or climbing. But their weight pressing downward would be much lower. A suit that would be exhausting on Earth might feel far easier to support on Titan. You could carry equipment that would be impossible to carry comfortably at home. Your steps would feel light, slow, almost floating. And because Titan's atmosphere is thick, movement would feel unlike movement on the moon. On the moon, you are in low gravity and vacuum. On Titan, you are in low gravity and dense air. Every motion would push against atmosphere. If you moved your arm quickly, you might feel resistance. If you jumped, you would rise higher than on Earth, but the thick air would slow your motion. You would feel light, but not weightless. Free, but surrounded. That combination would make Titan one of the strangest places to walk in the solar system. But surviving there long-term would require far more than a suit. You would need a habitat, a warm, sealed, powered shelter where humans could sleep, eat, repair equipment, process air, communicate with Earth, and recover from surface work. And that habitat would need energy, a lot of it. Solar power would be almost useless as a primary source. Titan orbits Saturn, far from the Sun. Sunlight there is already very weak compared to Earth. And Titan's thick orange haze blocks and scatters even more of it before it reaches the ground. A solar panel on Titan's surface would receive only a tiny fraction of the sunlight available on Earth. Enough maybe for small instruments, maybe slow charging systems, maybe backup sensors, but not enough for a serious human base. Not enough to heat habitats, not enough to power life support, not enough to generate oxygen, not enough to run communication systems, rovers, science labs, and suit recharging stations. For humans, Titan would need nuclear power. There is no realistic alternative for a long-term base. A compact nuclear reactor could provide steady electricity and heat through Titan's long dim days and cold environment. It would run the habitat's life support, heaters, lights, computers, pumps, medical systems, and communication arrays. It would also keep the base from freezing. And on Titan, that is not comfort. That is survival. A human habitat would probably use nuclear power not only for electricity, but also thermal management. Waste heat from the reactor could be captured and circulated through the base. Heat pipes and insulated loops could keep living areas warm, prevent water systems from freezing, and protect mechanical equipment. The base itself might be partly buried or shielded, not mainly because of pressure or radiation, but to stabilize temperature and protect from environmental wear. Inside, it would need to feel almost Earth-like: warm air, normal pressure, breathable oxygen mixture, artificial lighting, exercise areas, medical rooms, workstations, food storage, maybe small plant growth chambers for psychology, but not full farming at first, because food on Titan is another problem. Titan has organic chemistry everywhere. It has methane. It has hydrocarbons. It has water ice. It may even have a subsurface ocean deep below. But for humans standing on the surface, none of that becomes easy food or drink. There are no edible plants, no soil we can farm in, no liquid water flowing on the surface, no natural oxygen, no biosphere. The water is locked as ice, frozen as hard as rock at Titan's temperatures. In theory, humans could mine and melt water ice with enough energy, but early missions would likely bring water and food from Earth, because relying on local resources would be dangerous before the technology is proven. Food would arrive packaged, dehydrated, stored carefully, rationed. Every meal would have been planned years before. Fresh food would be rare unless small indoor growth systems were included. And if something went wrong with supplies, there would be no rescue shipment arriving quickly. Titan is too far. Communication alone would remind you of that distance every day. At Saturn's distance, a radio signal can take about 80 minutes one way to reach Earth, depending on where the planets are in their orbits. That means If you send a message home, Earth hears it more than an hour later. If they respond immediately, you wait another 80 minutes. A basic exchange can take nearly 3 hours. There is no live conversation, no real-time mission control, no quick medical consultation, no instant emotional support from family. Everything becomes delayed. A voice from Earth is not a voice beside you, it is a voice from the past. That delay changes what survival means. If someone has a medical emergency, the crew must handle it themselves. If a suit heater fails outside, Earth cannot talk them through it in real time. If the reactor has a problem, the base cannot wait for permission. If someone becomes sick, injured, panicked, or exhausted, the answer must come from the people already there. A Titan crew would need medical autonomy, surgical tools, diagnostic systems, trained doctors, robotic medical assistants, a pharmacy designed for years, emergency procedures for injuries, infections, mental health crises, equipment failures, and unknown environmental effects. Because on Titan, Earth is not close enough to save you. Earth can advise. Earth can listen. Earth can send instructions. But Earth cannot act. That responsibility would sit inside the habitat, with the crew. And over time, the psychological challenge might become as serious as the physical one. Titan is beautiful, but it is also strange in a way that could wear on the mind. The sky is always orange. There is no blue, no clear sunlight, no bright day like Earth, no normal sunrise, no natural warmth. The world outside would always look filtered, dim, hazy, and distant. At first, that would feel magical. An orange sky, methane clouds, dark dunes, frozen plains, alien rain. But after months or years, the same sky might become heavy. Humans are shaped by Earth's light. We respond to blue skies, sunlight, changing weather, green landscapes, open horizons. Our sleep cycles, mood, hormones, and sense of time are tied to natural light. On Titan, natural light would be weak and orange. The sun would appear only as a pale glow. Saturn might be hidden behind haze. The sky would never open into familiar blue. That could affect mental health deeply. People might begin to miss color, real daylight, the feeling of sunshine on skin, the sight of clouds in a blue sky, the smell of rain that is actually water, the sound of living landscapes. A Titan habitat would need to fight this, not just with oxygen and heat, but with psychology. Artificial day-night cycles, bright indoor lighting, blue sky simulation rooms, virtual reality environments, green plant chambers, private spaces, exercise, music, delayed but regular communication with loved ones, shared rituals, a calendar, a reason to keep going. Because survival is not only staying alive, it is staying human. Imagine waking every day beneath permanent orange haze, walking through a metal habitat while heaters hum in the walls, looking outside at a frozen plain where methane rain might fall, knowing that you are surrounded by thick air you cannot breathe, knowing that the ground beyond the airlock is cold enough to destroy life, knowing that every message from home takes more than an hour to arrive. At first, the wonder would carry you, but wonder alone cannot sustain a person forever. Routine would become essential. Work would become essential. Purpose would become essential. Science missions, surface walks, weather monitoring, methane lake studies, drone flights, sampling dunes, repairing instruments, checking the reactor, maintaining suits. Every task would remind the crew why they are there, but the isolation would never fully disappear. Titan would be one of the loneliest places humans could live, not because it is silent like the moon. It has wind, it has weather, it has sound, but because everything familiar is changed. The rain is methane, the lakes are hydrocarbon, the rocks are ice, the air has no oxygen, the sky is orange, the sun is weak. Earth is only a delayed signal, and yet Titan is also one of the few places where survival feels almost imaginable. Not easy, not natural, but imaginable. Because it has atmosphere, it has stable ground, it has low gravity, it has weather to study, it has surface liquids, it has chemical richness. A human could stand there with the right suit. A habitat could operate there with nuclear power. Rovers and drones could explore. A base could last, but only if every system works. Oxygen must be supplied. Heat must never stop. Food must be stored or grown inside. Water must be brought or extracted with effort. Communication must be accepted as delayed. Medical emergencies must be handled locally. And the mind must learn to live under orange skies. That is what surviving on Titan would really mean. Not walking freely through an alien paradise. Not breathing the thick air. Not watching Saturn clearly overhead. But living inside a protected pocket of Earth on a moon that almost looks welcoming from a distance and becomes stranger the longer you stay. Titan would not kill you with emptiness. It would surround you with atmosphere. It would give you wind, rain, a horizon, a sky, and then it would remind you that none of it was made for you. To survive there, humans would need to bring warmth into deep cold, oxygen into unbreathable air, light into orange dimness, and meaning into one of the loneliest landscapes in the solar system. Dragonfly is not a human mission. No astronaut will step out. No human voice will speak beneath Titan's orange sky. No boot will press into the dark organic sand. But in many ways, Dragonfly is the mission that must happen before humans can ever dream of going there. Because Titan is not just another world to photograph from orbit. Titan has air, weather, dunes, rain, lakes, seas, chemistry, and a surface that may preserve clues about one of the deepest mysteries in science. How does chemistry become life? That is why NASA chose Dragonfly, not a rover, not an orbiter, not a stationary lander, a flying machine. A drone helicopter designed to move across Titan's surface, lift into the thick orange atmosphere, travel to new locations, land, sample the ground, and do it again. On Earth, flying takes power. Aircraft need lift, wings need speed. Helicopters need strong rotors to fight gravity, but Titan changes the rules. Its atmosphere is thick, its gravity is weak. That combination makes flight easier there than almost anywhere else in the solar system. The air is dense enough to support a flying vehicle. The pull downward is low enough that lifting off requires less effort than it would on Earth. So on Titan, a rotorcraft becomes something extraordinary, not just possible, but ideal. Dragonfly can do what a rover cannot. A rover crawls, a lander stays, an orbiter watches from above. But Dragonfly can hop across the landscape. It can fly over dunes, cross rough terrain, move from one scientific target to another, explore not one place, but many. And that matters, Because Titan is not uniform. It is a world of different environments. Dark dune fields, organic-rich plains, impact craters, possible ancient melt zones, channels shaped by methane rain, regions where water ice and complex carbon chemistry may have interacted in the past. A single landing site would tell only one story. Dragonfly can read many. Its planned exploration begins in Titan's equatorial dune fields. These dunes are not like ordinary desert sand on Earth. They are believed to be made of organic particles, carbon-rich material created high in Titan's atmosphere, slowly falling down like chemical snow, then shaped by winds into dark waves across the surface. That alone is incredible. A desert made from the chemistry of the sky. Dragonfly will land in this kind of environment first because it offers both safety and science. The dunes provide a wide landing region, and the organic material there may hold records of Titan's atmospheric chemistry. Every grain may be part of a long chemical story. Methane and nitrogen broken apart by sunlight, reassembled into complex molecules, falling through orange haze, accumulating on the ground, waiting for a machine from Earth to arrive. But the mission does not stop there. One of Dragonfly's most important destinations is Selk Crater. Selk is not just a hole in the ground. It is a place where Titan's past may have briefly changed. When an impact strikes an icy world, it releases heat, it melts material, it breaks the surface, it mixes layers that may otherwise stay separated. On Titan, that matters deeply because Titan has organic material on the surface. It has water ice in the crust, and during an impact event, liquid water may briefly exist for a short time. In a localized region, water and organic chemistry could mix. That is the kind of environment scientists care about. Not because it guarantees life. It does not. But because it may create the conditions where prebiotic chemistry can advance. The chemistry before biology. The steps before life. Selk Crater may be one of the best places to search for that story. Dragonfly will investigate surface materials there, looking for chemical complexity. It will not simply ask, is there life? That is too simple and too difficult. Instead, Dragonfly asks something more precise. How far has chemistry gone? Are there molecules that suggest complex organic reactions? Did water and organics interact? Did Titan ever create environments where the ingredients of life could process together? That is the real mission. Dragonfly is searching for the chemical pathway, the bridge between raw molecules and biological possibility. And this is why Titan is so exciting. Because it is like a natural laboratory. Earth's early atmosphere may have once contained chemistry that helped life begin. But Earth has changed dramatically. Plate tectonics, erosion, oceans, biology, weather, and time have erased much of the ancient record. Titan, by contrast, is cold, slow, preserved. Its chemistry may hold clues to processes that happened on early Earth billions of years ago. Titan may not be alive, but it may preserve the kind of chemistry that came before life. And that makes it priceless. Dragonfly will carry instruments designed to study that chemistry directly. It will sample surface material. It will analyze composition. It will study geology. It will measure atmospheric conditions. It will listen to the environment. It will test what the ground is made of, how the atmosphere behaves, how materials vary from place to place, and what kinds of organic compounds exist. This is the kind of data we need before humans ever arrive, because a human mission cannot land blind. We need to know the surface. How soft is it? How stable? How dangerous? Where are the safest landing zones? Where are the most valuable science sites? How does the weather behave near the ground? How strong are the winds? How much dust or organic material moves across the surface? How cold does equipment become during Titan's long day-night cycle? What kind of terrain can vehicles cross? What regions should humans avoid? Dragonfly will answer questions that no telescope can answer. No image from Earth can tell us exactly how Titan feels near the ground. No orbiter can fully replace the experience of moving across the surface. Dragonfly will be the first true explorer of Titan's landscapes, not just landing once, but traveling, flying, sampling, learning, and every flight will matter. Imagine it sitting on Titan's surface, a car-sized machine under orange haze, its rotors still, its instruments cold but alive. Around it, dark dunes stretch across the landscape. The sky is amber, the sun is faint, there is no human sound. Then the rotors begin to spin, slowly at first, then faster. The thick nitrogen atmosphere starts to move. Organic dust shifts beneath the vehicle, and Dragonfly rises, a flying machine from Earth lifting into the sky of Saturn's largest moon. That image alone feels impossible, but it is exactly why Titan was chosen. Titan is one of the few places where flying exploration makes sense. A rover would move slowly across difficult terrain. A balloon could drift, but might not control exactly where it goes. A rotorcraft can choose. It can land. It can take off again. It can cross obstacles. It can target scientifically interesting areas. It can build a story from multiple locations. That makes Dragonfly one of the most ambitious planetary missions ever planned. And also one of the most important, because if Dragonfly finds complex organic chemistry that has advanced farther than expected, that would be enormous. If it finds strong evidence that liquid water once mixed with surface organics at Selk Crater, that would reshape how we think about Titan. If it detects chemical patterns that suggest energy flow, prebiotic reactions, or possible pathways toward life like chemistry, that would become one of the most important discoveries in astrobiology. A positive result would not automatically mean life exists on Titan, but it would mean Titan is chemically richer than we imagined. It would mean that even far from the sun, on a frozen moon wrapped in orange haze, nature can create complex steps toward biology. And that would change how we search for life elsewhere. Because life may not only begin on warm Earth-like planets, it may begin, or almost begin, in stranger places, cold worlds, ocean moons, organic skies, hydrocarbon lakes, impact craters where water and carbon chemistry meet for brief moments in time. Dragonfly could expand the definition of where chemistry becomes interesting. And if it finds nothing, that matters too, because absence teaches. If Titan has abundant organics, but does not show advanced prebiotic chemistry in certain environments, scientists can ask why. Is it too cold? Too dry in the wrong way? Too chemically slow? Does the lack of stable surface water limit everything? Does Titan preserve ingredients without letting them become more complex? Even a negative result would sharpen our understanding, because Titan is one of the best natural experiments in the solar system. and Dragonfly is how we begin to read it. For future human exploration, the mission is even more valuable. A human mission to Titan would require knowing the environment in detail, the ground strength, the weather, the atmosphere near the surface, the dust, the thermal conditions, the chemistry that might affect equipment, the best places to land, the best places to build, the risks of methane rain, the behavior of dunes, the reliability of flight in Titan's air. Dragonfly will collect the kind of ground truth that turns imagination into planning. Before humans can land, machines must land. Before humans can explore, machines must scout. Before humans can survive, machines must tell us what survival would require. That is why Dragonfly paves the way. It is not building a base, it is building knowledge. And knowledge is the first infrastructure. A map is infrastructure. Weather data is infrastructure. Surface chemistry is infrastructure. Landing site safety is infrastructure. Without those things, human exploration is fantasy. With them, it becomes a future engineering problem. Still difficult, still dangerous, but real. And this is why Titan may be one of NASA's most exciting destinations right now, because it is not just another icy moon. It is a world with atmosphere and organic chemistry, a world where flight is possible, a world where surface liquids exist, a world that looks strangely Earth-like while being completely alien, a world that may preserve clues about how life begins. And Dragonfly is the mission designed to touch that mystery directly, not from orbit, not from a telescope, but from the ground, from the dunes, from the crater, from the orange air itself. When Dragonfly arrives in the 2030s, it will not just explore Titan. It will change Titan from a distant idea into a world we know from the inside. And long before any human descends through that haze, Dragonfly will already have listened to the wind, touched the ground, flown under the orange sky, and asked the question that brought us there in the first place: how close can a frozen alien moon come to the chemistry of life? On Titan, the question of life does not begin with water, it begins in the sky. Because Titan's atmosphere is not passive, it is active, chemical, restless. High above the surface, sunlight is weak, but it is still strong enough to break apart methane and nitrogen molecules. Saturn's magnetic environment adds more energy. Cosmic particles strike the upper atmosphere. Molecules split, recombine, and grow into something more complex. And slowly, over millions of years, Titan's sky manufactures organic chemistry. Not life, not yet, but ingredients, carbon-rich molecules, hydrocarbons, nitriles, complex organics, particles that gather into the thick orange haze surrounding the moon. And then, like a strange chemical snow, they fall down through the atmosphere, onto the dunes, into the rivers, across the plains, and into the methane lakes and seas. Titan is not just a frozen moon, it is a world where organic material rains from the sky. That single fact makes Titan one of the most fascinating places in the solar system. Because on Earth, organic chemistry is tied deeply to life. Carbon is the backbone of biology. The molecules that make cells, proteins, membranes, and genetic material all depend on carbon chemistry. Titan is covered in carbon chemistry, but Titan is also cold, brutally cold, around -179 degrees Celsius at the surface, too cold for water to exist as a liquid on the ground. too cold for Earth-like biology to function. So the question becomes strange. Could life exist there anyway? Not life like us. Not plants. Not microbes swimming in warm water. Not cells using the same chemistry Earth uses. Something else. Something built for Titan. Something that uses the materials Titan provides. This is where the mystery becomes almost uncomfortable. Because Titan has many of the ingredients we associate with prebiotic chemistry. It has nitrogen, methane, hydrogen, complex organics, surface liquids, weather, stable environments, time, a lot of time, and one of the most important organic substances connected to Titan is called tholins. Tholins are not one single molecule. They are a mixture of complex organic compounds created when simple gases like methane and nitrogen are exposed to ultraviolet light or energetic particles. They are reddish-brown, sticky, complex, and on Titan, they may be everywhere. They are part of the haze, part of the surface deposits, part of the dark dunes, part of the strange organic material that covers the moon. On Earth, tholins do not naturally accumulate in the same way because oxygen and water chemistry change everything. But in laboratory experiments, tholin-like materials can produce molecules that interest astrobiologists, amino acid precursors, nitrogen-rich organics, chemical structures that hint at the earliest steps toward life-like complexity. Again, this does not mean Titan is alive, but it means Titan is not chemically boring. It is rich, it is active, it is producing complicated molecules without biology. And that raises one of the deepest questions in science. How far can chemistry go before it becomes life? On Earth, life uses liquid water as its solvent. Water is extraordinary. It dissolves many substances. It helps molecules move, react, fold, and organize. It allows life's chemistry to happen at temperatures where biological molecules remain flexible. But Titan's surface does not have liquid water, at least not stable on the surface. Instead, Titan has liquid methane and ethane, methane lakes, methane rain, methane rivers, methane seas. So scientists have asked a radical question. Could methane replace water? Could life exist in liquid methane? This idea sounds impossible at first. Methane is not water. It is much colder. It is less reactive. It dissolves different kinds of molecules. The chemistry would be slower, very slow. But Titan has time. Billions of years. A world where chemistry may move at a pace completely unlike Earth. If life existed in Titan's methane seas, it would not look like anything we know. It would not use water-filled cells. It would not have membranes like ours. It would not need oxygen. It might not use DNA. It might not even have metabolism in the way we understand metabolism. It would be alien in the truest sense. Not a monster. Not something dramatic. Maybe microscopic. Maybe slow. Maybe fragile. Maybe so chemically different that recognizing it would be one of the hardest scientific challenges ever faced. Imagine a form of life that exists inside liquid methane. Its cell-like boundary would need to work in extreme cold. It would need to stay flexible, where Earth membranes would become useless. It would need to manage energy with chemical reactions that barely resemble Earth biology. It would need to build structure from molecules stable in hydrocarbon liquid And because Titan is so cold, everything might happen slowly. Growth, movement, reaction, reproduction. If it exists at all, Titan life might live at a rhythm we would barely recognize. This is where the cell membrane hypothesis becomes important. On Earth, cells are surrounded by membranes made from molecules that work well in water. But in methane, those molecules would not behave the same way. So scientists have proposed alternative membrane-like structures that could exist in Titan-like conditions. One idea imagines membranes made from small nitrogen, containing organic molecules, able to form flexible, stable boundaries in liquid methane, a kind of alien cell wall, not made like Earth cells, but doing the same basic job, separating inside from outside, creating a protected chemical space, allowing reactions to happen within a boundary. That is one of the first steps toward life. A living thing must have some form of separation, some way to maintain itself against the outside environment. If Titan chemistry can create structures like that, then the possibility of life becomes more serious. Still not proven, but more imaginable. Some scientists believe Titan is one of the most important places to search for exotic life, because it gives us a chance to test whether biology must always be water-based. Maybe life requires water. Maybe Earth's chemistry is the only practical path. But maybe not. Maybe life is not one recipe. Maybe it is a broader process, a way for chemistry to organize itself, use energy, and persist. If that is true, then Titan may be one of the best natural laboratories in the solar system. Because Titan challenges our assumptions. It asks whether life can exist in a liquid that is not water. It asks whether cold chemistry can still become complex. It asks whether a world can be biologically interesting, even when it seems completely hostile to us. And then there are the anomalies, the strange hints, the things Cassini measured that still make scientists pause. One of them involves hydrogen. Models suggested that hydrogen should be produced in Titan's atmosphere and drift downward toward the surface. But observations showed something unusual. Hydrogen seemed to flow down through the atmosphere and then disappear near the surface. Something was removing it. Now, this does not mean life is eating hydrogen. That would be too simple. There may be non-biological explanations. Surface chemistry, atmospheric processes, unknown reactions with organic material. Titan is complex, and we do not fully understand it. But on Earth, hydrogen can be used as an energy source by some microbes. So when scientists saw hydrogen behaving strangely on Titan, the possibility was raised. Could something on the surface be consuming it? Could chemistry there be using hydrogen in a way we do not yet understand? It is not proof, but it is interesting. Then there is acetylene. Acetylene is another molecule expected to form in Titan's atmosphere and fall to the surface. Some models predicted it should accumulate there, but observations suggested there may be less acetylene on the surface than expected. Again, this is not evidence of life by itself. There are many possible explanations. Maybe our models are incomplete. Maybe acetylene reacts with surface materials. Maybe it is hidden. Maybe it is transformed by chemistry we have not fully mapped. But the reason it attracted attention is because acetylene could, in theory, be an energy source for methane-based life. A hypothetical organism living in Titan's methane lakes might use hydrogen and acetylene in chemical reactions to gain energy. So when hydrogen appears to disappear near the surface and acetylene seems lower than expected, some scientists ask the question, not as a conclusion, but as a possibility. Is there chemistry happening there that we do not understand? Could it be purely chemical? Or could it be something stranger? That is the beauty of Titan. It does not give us answers easily. It gives us mysteries that sit between chemistry and biology. A methane sea may be only a sea, a dark basin of hydrocarbons under orange haze. But it may also be a place where molecules interact for millions of years, where organic material from the sky dissolves into liquid, where reactions happen slowly, where new structures form, where nature tests possibilities that never occurred on Earth. If life exists in Titan seas, it might not swim like fish. It might not form mats like algae. It might not create colors visible to the eye. It might be microscopic, suspended in liquid methane, attached to sediment, living at the boundary between shore and sea, using hydrogen, transforming acetylene, building membranes unlike anything on Earth. Or it may not exist at all, and Titan may simply be a world filled with almost life, a place where chemistry walks right up to the edge of biology, but never crosses. That would be profound too, because it would show us that ingredients alone are not enough, that life requires something more. Energy, stability, temperature, the right solvent, the right environment. Maybe Titan has everything except one missing piece, or maybe it has the piece, and we have not looked closely enough. This is why Dragonfly matters. This is why future missions matter. Because from Earth we can imagine, from orbit we can infer. But to know Titan, we must touch it. Sample the dunes, analyze the organics, measure the chemistry near the surface. Study impact sites where water and organics may have mixed. Eventually, maybe send a probe into the methane seas. Maybe one day, a submarine into Kraken Mare. Because the truth may not be in the sky alone. It may be in the liquids, in the sediments, at the shorelines, in the places where rain, organics, and frozen ground meet. And if we ever found life there, even the simplest life, the universe would change, because Earth would no longer be the only living world we know. And if life began twice in one solar system, once in water on Earth, and once in methane on Titan, then life would not be rare. It would be everywhere, not literally everywhere, but common enough that the universe could never again feel empty. Every exoplanet, every icy moon, every world with chemistry and liquid, every orange haze around a distant planet, suddenly all of them would become more meaningful, because life would no longer be a miracle that happened once. It would be a pattern, a cosmic habit, something matter does when conditions allow it. That discovery would change biology. It would change astronomy. It would change philosophy. It would change how we look at the stars. And it would change how we look at ourselves. Because if Titan has life, then life does not need Earth-like comfort. It does not need blue skies. It does not need oceans of water on the surface. It does not need warmth as we know it. It can emerge in darkness, in cold, in methane, under orange haze, on a moon of Saturn. And that would mean the universe is far more alive than we ever dared to imagine. But for now, Titan keeps its secret. The orange atmosphere continues making organic molecules. The haze continues falling. The methane seas remain dark and still. Hydrogen disappears near the surface for reasons we do not fully understand. Acetylene remains part of a mystery not yet solved, and somewhere, perhaps in a lake, a shoreline, a dune field, or beneath the ice, Titan waits, not offering proof, only possibility, and sometimes possibility is enough to keep humanity looking. Titan changes everything because it refuses to fit into one category. It is a moon, but it behaves like a planet. It is frozen, but it has weather. It is deadly, but it looks strangely familiar. It has rivers, lakes, clouds, rain, dunes, shorelines, seasons, and a thick atmosphere. And yet every familiar thing is made from something alien. The rivers are methane, the seas are hydrocarbons, the rocks are water ice, the sky is orange, the sunlight is weak, the air is unbreathable. Titan is not Earth, but it is the closest thing to an alternate Earth that we have ever found. Not because it could support humans naturally, it could not. Not because it has forests, oceans, animals, or breathable air. It has none of those. But because Titan shows us something profound. It shows us that worlds can build Earth-like systems. Without Earth-like ingredients. That is what makes it so important. On most moons, geology is written in craters, impacts, fractures, frozen plains. But on Titan, the landscape is shaped by atmosphere, by weather, by liquid movement, by chemistry falling from the sky. Titan has a climate system, a methane cycle, a surface that changes, and that makes it one of the most valuable places in planetary science. Because Titan teaches us that planets and moons are not defined only by warmth, sunlight, or water. They are defined by systems, by how atmosphere, surface, liquids, and chemistry interact over time. On Earth, water evaporates from oceans, forms clouds, falls as rain, carves rivers, fills lakes, and returns to the sea. On Titan, methane does something similar. It evaporates, condenses, falls, flows, pools, returns, a cold mirror of Earth's water cycle. And that mirror changes how we understand planetary behavior. It means that the universe can repeat patterns in different materials. A river does not have to be water. A sea does not have to be blue. A sky does not have to be breathable. A world does not have to be warm to be active. Titan expands the meaning of what a world can be. And then there is the chemistry. High above Titan's surface, sunlight and energetic particles break apart methane and nitrogen molecules. Those fragments recombine into more complex structures. Organic compounds form. Haze particles grow. Tholins gather. And slowly, they fall. For billions of years, Titan's atmosphere has been raining chemistry onto its surface, not life, but the ingredients that make life interesting. Carbon-rich material, nitrogen-bearing molecules, prebiotic chemistry, the kind of chemistry scientists believe may have been important on the early Earth. That is one of Titan's greatest scientific gifts. Earth's early chemistry has been mostly erased. Our planet is alive, active, and constantly recycling itself. Plate tectonics reshape the crust. Water erodes old rocks. Life consumes and transforms chemistry. Time has buried the beginning. But Titan is different. Titan is cold, slow, preserved. A natural laboratory where organic chemistry can accumulate without being immediately destroyed by biology. In a strange way, Titan may show us something about Earth before life. Not an exact copy, not the same temperature, not the same ocean, not the same atmosphere, but a place where simple molecules become complex molecules. A place where carbon chemistry grows richer with time. A place where nature experiments. That is why Titan matters for understanding the origin of life. Not because it proves life exists there. It does not. But because it shows us the steps before life may be common. The universe may be full of worlds where chemistry becomes complex. Worlds with haze. Worlds with organic rain. Worlds with liquids. Worlds where carbon molecules gather and transform. Titan tells us that complexity does not require a living planet. It can happen naturally, in the cold, in the dark, under orange clouds. That realization changes how we search for life elsewhere. For a long time, we looked mostly for Earth-like conditions. Liquid water, moderate temperatures, sunlight, rocky planets. And those are still important. But Titan asks us to think wider. Could life exist in a liquid other than water? Could chemistry organize itself in methane? Could a cold world preserve the ingredients of biology for billions of years? Could life begin in places we once dismissed as too strange? Even if Titan is lifeless, it still changes the question. Because it shows that the path toward complexity may begin in many environments. Warm oceans are one possibility, but maybe not the only one. This is why Titan is one of the most powerful worlds in astrobiology. It sits at the edge of possibility, not clearly alive, not clearly dead. A place that does not answer the question, but refuses to let us stop asking it. And if one day we did find life there, everything would change, especially if that life was different from Earth life. If Titan had methane-based life, or some kind of unfamiliar chemistry living in its lakes or sediments, it would mean biology is not limited to one formula. It would mean life can emerge in more than one way. Water-based life on Earth, hydrocarbon-based life on Titan. Two separate paths, two different chemistries, one solar system. And if that were true, then life would no longer feel rare. It would feel like something the universe does naturally when conditions allow. The stars would look different after that. Every distant exoplanet would feel more alive with possibility. Every icy moon would become more important. Every hazy atmosphere around another world would become a question. Titan would not just change science. It would change our sense of the universe. It would make the cosmos feel less empty, less silent, more fertile, more mysterious. But Titan also changes something about us, because eventually after Dragonfly, after future orbiters, landers, maybe submarines, maybe sample missions, the human question will return. Could we go there? Could humans one day stand on Titan? Not just send machines, not just receive images, but arrive, walk, listen to the wind, watch methane rain fall through orange haze, stand at the shore of Kraken Mare, and look across an alien sea. Realistically, that is not near. Titan is far beyond Mars. A human mission to Saturn's system would require technology, funding, patience, nuclear power, deep space habitats, psychological endurance, and years of travel. It may not happen this century, or it may happen near the very end of it if humanity advances faster than expected. More likely, a human landing on Titan belongs to a future generation, a generation that has already learned how to live on the moon. how to survive on Mars, how to build closed habitats, how to use nuclear energy safely in space, how to operate far from Earth with long communication delays, how to send humans beyond the inner solar system. Titan would require more than a mission. It would require a civilization capable of long commitments. Not one launch, not one political cycle, not one company, not one nation. A generational project, the kind of undertaking that begins with robotic scouts, continues with orbital stations, surface power systems, landing infrastructure, and only later sends humans. And that may be the real challenge. Not whether Titan is physically reachable. Physics allows it. Engineering may one day allow it. The question is whether humanity can remain committed long enough. Titan asks us to think beyond short lives, beyond immediate reward, beyond the next decade. Because the worlds that matter most are not always the worlds that are easy to reach. Sometimes they are the ones that force us to become patient, careful, serious. A human mission to Titan would mean that our species had matured into something new, not just explorers of nearby space, but travelers of the outer solar system, people capable of crossing more than 1 billion kilometers to stand under another sky. And imagine what that moment would feel like for our descendants. After years of travel, they descend through the haze. The orange atmosphere surrounds the lander. The parachutes open. The wind begins to whisper against the hull. Below, the surface appears slowly. Dark plains, frozen channels, organic dunes, maybe the black edge of a methane sea. Then touchdown. A soft landing on frozen ground. The air outside thick but unbreathable. The sun only a dim glow. Saturn faint behind haze. The crew steps down. Their boots press into a surface made of ice, organics, and ancient chemistry. Their bodies feel light under Titan's weak gravity. Their suits keep them warm against the impossible cold. And in front of them, Kraken Mare, a dark sea, larger than some of Earth's greatest bodies of water. Silent, reflective, alien. No waves crashing, no birds, no salt smell, no blue horizon. Just a black hydrocarbon sea beneath an orange sky. In that moment, they would understand something that images can never fully show. Titan is not just a place to study, it is a place to feel. A world with presence, a world with atmosphere, a world that surrounds you. And perhaps they would think of Earth, not because Titan looks exactly like it, but because Titan reminds us what Earth is, a world of air and liquid, and chemistry and time, a world that could have been different, a world that became alive. Standing on Titan would make Earth feel even more precious because Titan has so many of the shapes of home, but not the warmth, not the breath, not the life. It is like seeing the outline of Earth without its soul. And that is why Titan changes everything. It teaches us what makes a planet active. It teaches us what chemistry can do without biology. It teaches us that familiar landscapes can be built from alien materials. It teaches us that life may require less than we thought, or perhaps something more mysterious than we understand. And it teaches us humility, because we once thought Earth was unique in almost every way. Then we found rivers on Mars, oceans beneath icy moons, organic chemistry in comets, exoplanets around distant stars, and methane seas on Titan. Again and again, the universe tells us the same thing. Earth is special, but the processes that shaped it are not isolated. Nature repeats itself, changes ingredients, builds variations, creates worlds that feel like echoes of home. Titan is one of those echoes, a cold echo, an orange echo, a world where Earth-like beauty exists without Earth-like life, at least as far as we know. And that uncertainty is what keeps the story alive. Maybe Titan is lifeless, a frozen chemical laboratory, a place where organic molecules gather, shift, dissolve, and settle, but never awaken. Or maybe somewhere in its methane seas, or in its sediments, or deep beneath its icy crust, something is happening. Something slow, something strange, something we do not yet know how to recognize. And until we go closer, Titan keeps that secret. Tonight as you drift to sleep, imagine standing at the shore of Kraken Mare, an orange sky above you, a methane sea before you, Saturn faintly visible through the haze, the air thick around your suit, the wind moving softly across the frozen shore, and the profound realization that you are standing on a world that has been waiting billions of years for someone to finally arrive